transportation in the 5 boroughs by Alonso and Bohn. This is our table of contents, and now for the introduction. So we really chose to focus on New York because Juliet's from New York and we wanted a personal connection to our project. And then really the objective of our analysis is to examine the correlation between electric vehicle adoption, bicycle usage, and air quality in New York City. By focusing on these variables, we aim to uncover trends and relationships that can inform sustainable urban development. So to achieve this, we use 3 different data sets, one on air quality data, which includes key pollutants such as nitrogen dioxide and fine particle matter, and then cycling data, which tracks the total annual cycling trips across New York, and then electric vehicle data, which showed electric vehicle adoption trends within New York City's 5 boroughs. So the scope of our project is specific to the New York City's 5 boroughs, and this ensures that we maintain an accurate focus on the greater New York City area. And our goal is to explore how these factors, such as electric vehicle adoption and cycling activity, might positively impact air quality. So by analyzing this data, we also aim to predict long-term environmental and health trends. So a little bit more background. This research is important because New York City is an urban area that's facing significant air quality challenges due to its dense population and traffic congestion. And as cities transition to more sustainable transportation methods, understanding these impacts becomes crucial. So some of the transportation trends in New York, like more background. So the city has historically relied on fossil fuel powered vehicles, which is a major contributor to all air pollution. And then in recent years, cycling has grown significantly as it is supported by the expanded infrastructure and just a push towards cycling in the city. And electric vehicle adoption has also been gaining momentum as New York City pushes for cleaner transportation alternatives. And this really ties directly to environmental concerns, as pollutants like NO2 and PM2.5 are harmful to respiratory and cardiovascular health, especially in urban areas with high traffic and congestion. And 2 of these measures that we focus on are PM2.5, which is a fine particle matter, which directly impacts respiratory health, and then NO2, which is a pollutant that's often linked to vehicle emissions. So this research is important because it helps us understand the relationship between sustainable practices and air quality improvements. So for our data sets, the first one is a CSV that had different air quality metrics in different areas of New York State, not just the city. So we filtered out to make sure it was including the counties we wanted, and then the years we wanted to be fairly compared to the other 2 data sets. I used regex to get rid of non-digit values in the data values, and then we used aggregates to sum up these data values by the borough. And then I made another section of it that was New York whole, which I just combined all 5 boroughs to be able to use that to compare with the other ones that had New York as a whole. So this is a before and after what it looked like, just a lot more simplified and easy for analysis. Our next data set was a web data set, that had a bike table. And so for this, I used Beautiful Soup and focused on the rows that had 2017 through 2022, which were in the other 2 data sets. And then for the extraction, I iterated through the tables, cleaning and removing commas to be able to get just the data value from the cells. So this is the before and the after, just the data that we needed for our analysis. And for the last one, it was a JSON, and this included every electric vehicle bought in the different areas of New York. So we focused on the 5 New York City counties: Kings, Bronx, Queens, New York, and Richmond. And then we renamed the columns to make it easier to read, and then aggregated each vehicle as a count to get a total number of the vehicles that were bought in each county in each year. So this is the before and after.
So now we're going to move on to the insights and the data visualizations. So we had 5 insights and 3 data visualizations for our project. So here is our first insight, number 1. So what this contained was the year, the total annual cycling trips in New York City, and for this we used millions. This was right from our clean data. And the next thing that we wanted to show was the different pollutants in the air. So we sorted this by year. So It was 2017 to 2022, and in this, we would have fine particles first and then NO2 levels second. And then also what we wanted to do was show the vehicle count in summation for all the 5 counties. So insight number 1, really what we wanted to show with this was how much, I guess, as a whole, this really affected everything. And that's where our insight explanation is at the bottom. So next, for our insight number 2, we really wanted to show the total of the NO2 and the PM2.5 values over time. And we were shocked to see that these actually decreased over time, except for that one little hiccup in the year of 2021, which we believe was after COVID-19. And that's why it hiked up a little bit and why there was such a dramatic increase from 2020 to 2021. So that is why. So basically, our explanation for this was as time increases, NO2 and PM2.5 values decrease. And we had a little hypothesis that this was because of the cycling and the electric vehicle usage. So with this, we showed visualization number 1, which was a bar graph between NO2, which is in blue, and the PM2 levels in New York City. So really why we wanted to show this was to kind of separate the two and show that the blue, which was NO2 levels, decreased more rapidly over time, and this is because the blue was due to vehicle usage while the red was due to just industry processes. Insight number 3, we wanted to show the absolute versus percent growth of electric vehicles by counties, and then we sorted this in descending order by percent growth. So New York City had the most, which was Manhattan, and then Richmond County, which is Staten Island, had the least, and we think that this is due just to policy enactments and demographics of the people that live there. So visualization number 2, we decided to show this in a big table or choropleth, and this showed the percent growth from the insight before this, which was insight number 3. So we did this to kind of show visually what the electric vehicle increase looked like. And this was no shocker to us, just again, because Staten Island is a lot more densely populated. It's really not that populated compared to Manhattan, which is why there was more EVs just due to policies and people's beliefs and things like that. And it was actually really interesting because Brooklyn and the Bronx had around the same level of percent increase. So insight number 4, we wanted to show the vehicle count compared to the NO2 levels. We did not include PM2.5 in this because that, as I said before, is more related to just like industry processes and things like that. And then we had a notable outlier, which I would like to talk about, which was a slight increase in NO2 levels in 2021, and this is because of the COVID-19 pandemic. Also, one more thing, this is why we couldn't have the best data on the year of 2020 to 2021. So this is our final insight. So we wanted to show the total accumulated pollution of the 5 boroughs, and then that top column, New York City, that's all of the data, and all the boroughs included. So that was kind of a summation of all of them. So that's not included in the descending order. We just wanted to really place it at the top. So this shows that Manhattan had the highest total accumulated pollution, while Staten Island had the lowest. And the factors that really led to this was the lower tourism in Staten Island and then the density as well. It's more sparsely populated. So this is our final visualization. We wanted to do a scatter graph of air pollutant, total annual cycling trips, and then EV registered. And we did this vertically to kind of keep in line the year for more readability. And this kind of proved what we thought it would be. So the electric vehicles and the cycling trips, as those increased over time, air pollutants decreased, which was pretty shocking to us, but then as we looked and we did more analysis, it was pretty believable as to why. Next, our final thing was that we created a GUI just so users can kind of view our data more efficiently, because we know that there's a lot of data in this and it's a little bit confusing. So what this shows is just a drop down of the year from 2017 to 2022, and then the columns are year, millions of annual cycling trips, NO2 emissions and PPB, and then total EVs. So that's what's in the tuple right there, that data. And here's our code below to show that. Finally, this is our conclusion. So project takeaways and conclusion. Our initial goals were explore relationships between EV adoption, cycling, and air quality. And we noticed, as said before, as time progressed, the other 2 factors increased, which lowered NO2 levels. So we wanted to assess whether EV and cycling usage positively impacts air quality, which yes, it does. And then we wanted to predict long-term trends. So we think that this will continue as long as gas vehicles are incentivized and So gas vehicles are incentivized and cycling is discouraged, which will kind of alter the results. And then personal takeaways: due to this project and its discoveries, we both become more eco-conscious and aware of our time spent in emission-producing vehicles. And we're both very interested in converting to electric vehicles, and I will be bringing a bike